Hey everybody, hope you're doing well. Today's lesson is going to be on the different types of regression. So last week we talked linear regression. Today you'll look at exponential and quadratic. This is just going to kind of help take you through the process on how to do the other regressions, exponential and quadratic, using your TI Inspire. So I've already got three problems um, set up to take a look at. So this first problem here, this is just coming from Delta Math. So you're in the assignment. Let's say this is one of the problem types that you're given. One thing that you'll need to be able to recognize is in here, it's going to tell you what type of regression. So in this case, write the linear regression equation. So that's going to let you know, hey, am I doing a linear regression? Am I doing an exponential? Am I doing a quadratic? In the eMath video, you'll see where he shows you some examples of, visually being able to look at a scatter plot and identify it. Here, they're just going to come out and tell you. If you want to create the scatter plot on your own, that's also fine. So let me clear this out, and then we'll kind of get started going through this process. So for a linear regression problem such as this, here's my table of values. I've already got all that stuff entered, so just a quick refresher. I'm going to go Menu, Statistics, Stat Calculation, and then I can choose Linear Regression, MX plus B. You're going to see some things pop up here because I've already entered several problems to have them set up to make the video a little quicker, but I'm going to use X1 because that's the problem that I had there. And then for my Y values, this is Y1. And then I'll just go ahead and hit OK. And then you'll notice it's going to give you everything you need. Here's your slope. Here's your Y-intercept. Remember, if you click on these values here, down here, if it's something that you need to round, that's the other thing that you want to be aware of. Here it says linear regression equation that represents rounding all the coefficients to the nearest tenth. Okay, so make sure you're aware of the rounding. Sometimes it'll be tenth, hundredth, thousandth, 10,000th even, so just be aware of that. Once you've got the equation, so I could come right down here and we could go ahead and enter this in. Y equals 21.9 times x plus 84.8. I could go ahead and enter my equation. And then with these linear problems, just like you had last week, it says use that equation to estimate the calendar year in which the profits would be $261,000. So if I was going to, solve for the year, let's see, last week I ran out of room, so let me see if I try starting in a different spot. I think they said 261. So the profits was 261. And then here is how I'm going to set that equal. And then I also showed you last week how you could solve this by graphing, just as a refresher. So if you remember, you could do this algebraically, subtract the 84.8, and then go ahead and do your division. That's one way in which you could find and then approximate your year accordingly. The other way, if you recall from first semester and throughout our Honors Algebra 1 course, you can always graph the left side, then you can graph this right side, and then you could look for that point of intersection where that would occur. So that kind of takes you through that process. Clear this out here, close, and then just a refresher as well. If you don't happen to have your TI Inspire with you at home, go ahead and click copy the values, open the stats calculator, paste those values in there, change this to the calculator menu, and then what type of a calculation do we want to do? We want to do a linear regression. Some of you might see this. This is a natural log, which is a different type of regression. Kind of goes along with exponential. This would be something that you would potentially dive into further in Algebra 2. So here's our linear regression, AX plus B. That's what I'm going to choose. I'll click Calculate. And then if you notice, here's my 21.9, there's my 84.8, and those values match right there. So that kind of gives you the ability to then go back to your problem, enter your equation, and then do your solving to find that value. All right, so there's kind of a walkthrough on the linear, just a refresher. So let's go to maybe an exponential problem here. And on this one, what you'll notice is kind of blocks it off. So I'll close that out since it's not going to be much help. But here is exponential regression equation. So that's going to be your indicator on, as you're reading these problems, is it linear? Is it exponential? Is it quadratic? And then once again, keep in mind you're rounding in this case to the nearest hundredth. And then they want you to use that equation to determine the value of the car to the nearest cent um, after 11 years. So they're going to tell you the input, and then you'll plug that in to get the output. So maybe a little bit easier calculation there, doing an input versus the other way around, like we had on that last example. All right, so with that being said, let me switch over here. I already had these values entered in. All right, so you can take the time and you can kind of go through there. I'm going to enter them, list and spreadsheet, just like we had. So here's the one little difference in terms of how we can generate this. We're going to go statistics, stat calculation, and then down here, instead of choosing linear, I'm going to choose exponential regression. Once again, you're going to see some additional things pop up here that you won't have on yours. I called this data X2 and Y2, so that's what I'm going to choose. I'll hit OK, and then it's going to show me everything that I need right here. And then remember, exponential is in that form of A times B to the X power. So there's my A value, there's my B value, and I've got everything I need to write that equation. Same thing could be done over here if you don't have your TI Inspire. Copy the values, open the stats calculator, paste them in. Go ahead and switch this to the calculate menu. And then in this case, slide down here and choose exponential regression. And you should notice you're going to end up with the same values. One little reminder, since we see this value that we're going to be multiplying repeatedly by is below a value of 1, then we would know that that's an exponential decay, or it's something that's getting smaller as time goes on. We can switch back to our table of values here. And then we could go ahead and enter this in. I think our rounding was to the nearest hundredth. All right, so we'll go ahead and enter this in. Y equals, and let me click on here to the nearest hundredth. Looks like this would be tenth, hundredth, so thousandth. So that's going to make that a 99. So 2893.99. And then in parentheses, click on this. And let's see, tenth hundredth, so 0.88 it looks like, 0.88. And then that will be raised to the x. So I'm going to enter that in as an exponential, not as a y equals mx plus b. It's got to be entered as an exponential function. And then this is maybe a little bit easier calculation. And if you don't have your TI Inspire, I'll kind of show you here in a second how you can use the calculator within Delta Math to help you answer. It says determine the value of the car to the nearest cent after 11 years. So if you don't happen to have your calculator, you could go up here and click calculator. That brings the calculator up within Delta Math. And then what you could do is you could just type in 893, that equation, 0.88. And then when you get here, just go ahead and throw that into an exponent, change that to 11 and hit enter. This is going to tell you your value. And then if I scroll up here, I just want to make sure it says the value of the car to the nearest cent. Okay, so here would be to the nearest cent looks like 72 cents. So let's just see how I did here. $5,120, and it looks like 72 cents. And close that calculator out. We'll submit that. We'll see how we did. Did a nice job with that. All right, so that's an example of an exponential. And the last one that we have here that we'll kind of run through is a quadratic. So if you take a look, write a quadratic regression equation, and then they want this rounded to the nearest tenth for the equation. All right, so let me go over here to page 3. I've already got all this data entered in. Once again, make sure as you go through there, you get it entered in accurately. Missing a decimal or having a wrong value in is going to throw things off. So just make sure that you do a nice job of being accurate as you enter it. So menu, statistics, stat calculation. Here's our linear, and then here's our quadratic. There's our exponential. So it's the same process. You just have to make sure that you're choosing the proper regression. So in this case, quadratic. This was my third data set. I had entered them all at once. So there's x3, and y3, my third set of data. I'm going to hit OK. And there we go. And then you'll notice here, this is going to tell you ax squared plus bx plus c, standard form of a quadratic. And then there are your three values. All right, within Delta Math, if you don't have your TI Inspire, copy the values, open the stats calculator, paste those values, go ahead and switch this to the calculate menu, and then go ahead and choose quadratic regression. And then you should notice that these values coincide exactly the same as what that's going to calculate for you there. All right, so let's go back here and let's just refresh on what they wanted us to round to. They wanted nearest tenth for the equation. All right, so y equals to the nearest tenth looks like negative 16.5x squared. And 181.9, so plus 181.9x, and then our c value looks like 1.5, so plus 1.5. All right, so I've got my equation, and then it wants to know, use that equation to find the height. So it wants to find the output when they give you an input value or a time of 3.9. So when I come down here, just like we did on that last one, you're going to go ahead and put a 3.9 in here, 3.9 in here, and then go ahead and you can solve that. I don't have the calculator handy. Guess I could use my TI Inspire over here, but in case, this is kind of nice. You can just type in negative 16.5, and it was 3. Just want to make sure I've got that right. 3.9. So 3.9, that's going to be squared, plus 181.9 times 3.9 plus 1.5, and I can hit enter. And then it tells us they want that equation, find the height to the nearest foot. So to the nearest foot, as I'm taking a look right here, this would be 460 feet. Go ahead and submit that. Yes. And got one correct. All right. So hopefully, not too much changes in your routine of things. Be aware on those linear regression equations that they could potentially give you an input or an output. When it comes to the quadratics and it comes to the exponentials, a lot of times they're going to give you the input value and you'll be finding the output. But this is going to give you the skills there to kind of go through. When you watch that eMath video, you can kind of follow along and enter some things in as he's going through that as well. Thanks.